So then, continuing on with parametric equations, we'll look next at arc length. So we know how to find arc length. We did this in chapter 8, I believe, a little while ago before the series. And this will be kind of the same thing. So we have a new formula here. So the arc length will be, I guess we could call it L, will be the integral from alpha to beta, which is the range of t, and very similar looking formula that we had before. So let's see how this works. So we need to find x prime and we need to find y prime. So we have x prime is 6t, y prime is 6t squared. And then t goes from 0 to 1. So our arc length will be the integral from 0 to 1, square root of 6t squared plus 6t squared squared dt. And so now let's simplify. So we have 36t squared plus 36t to the fourth dt. So we can pull the 36t squared out. So square root factor 36t squared, and then we have 1 plus t squared left. dt, and so then we can pull this part out of the square root, so that leaves us with 6t square root of 1 plus t squared dt. And so now maybe use u substitution, so we can let u equal 1 plus t squared. Du would be 2t dt. Let's look at our integral. And I guess before we do that, we have 6t here, we have 2t here. So we need to multiply this by 3. We actually need 3 du to equal 6t dt. Then let's look at our limits of integration. So when t is 1, u would be 2. And when t is 0, we plug in 0 here, and we get that u is 1. So now our integral is from 1 to 2. 6t dt is going to be 3 du. So this will turn into 3 square root u du. Integrate square root u. This will be u to the 3 halves divided by 3 halves. So 3 divided by 3 halves will give us 2 u to the 3 halves from 1 to 2. This will give us 2 times 2 to the 3 halves minus 2. And so we can rewrite this. This could be 2 times 2 times square root of 2, which would be 4 square root 2 minus 2. Or you could write 2 to the 5 halves. Either way, I think is fine. All right, then last one we'll look at is the surface area, which again, we saw surface area in the integration part, and this is the same idea. We're going to rotate around the x-axis, and here is our surface area formula. So again, we need x prime, we need y prime. So x prime here is going to be 3 minus 3t squared. Y prime is going to be 6t. And so now let's plug it into the formula. And so we have s equals the integral from 0 to 1, 2 pi. Now y, so y is 3t squared. So 3t squared times the square root of x prime squared. So 3 minus 3t squared squared plus y prime squared, so 6t squared. Now let's simplify whatever we can. So we have 6 pi t squared out here. FOIL this out, so we get 9 minus 18t squared plus 9t to the fourth plus 36t squared dt. We can go ahead and pull the 6 pi outside the integral. No reason to leave it in there. We have t squared here Let's combine our like terms. So we have 9 plus 18t squared plus 9t to the fourth dt. Now we can factor out a 9 from this. When we pull the 9 out, the square root will become a 3. So we have 6 pi 3t squared. That'll leave us with 1 plus 2t squared plus t to the fourth dt. Let's pull the 3 out. So that'll give us 18 pi out here. 0 to 1 t squared. This will turn into 1 plus t squared squared dt. Of course, the square and the square root will cancel. So that gives us 18 pi 0 to 1 t squared times 1 plus t squared dt. Let's come up here to finish. So that gives us 18 pi integral from 0 to 1. Distribute our t squared, so we get t squared plus t to the fourth, and now it looks pretty easy. So we have 18 pi times 1/3 t cubed plus 1/5 t to the fifth, 0 to 1. And so now just plug in 1. 0 obviously doesn't do anything. Plug in the 1/3 plus 1/5 times 18 pi. That will give us a final answer of 48 pi over 5. Okay, so conceptually nothing new. Mostly the trick on this is just kind of working the algebra to get down to something that you can actually integrate, which may or may not take a few steps, as you can see, but no big deal. If we get a trig problem, maybe have to use some identities, but nothing we haven't seen and done before. So if you have any questions on any of this, please let me know.